Wait, Brian, you're telling me you remember that sketch on the news?
Okay, here we go. So, harken back with me to Friday when we learned how to do law of sines. Yes. Harken back.
What is that?
It's an old English word. It's so much fun. Yes, harken. Okay. If you know an angle and you know its opposite side, then you can do law of sines. Okay, if you know the angle and an opposite side, you can do law of sines, except for what I show you later, which will just totally ruin this. I know. Well, what if we had a triangle and all I knew from that triangle was just the sides? Go back to geometry with me. In geometry, you would call this side, side, side. Remember doing that? Side, side, side. Okay. Or if I knew an angle in between, which we call side, angle, side. Okay. Side, an angle in between, and side. If you knew the angle B, let's say, then you can do law of cosines. If you know all the sides, or you know a side, an angle in between, and another side, then you can actually do law of cosines. Law of cosines has 3 formulas to it, but honestly, you really only have to kind of memorize one because you can see the pattern for the other 2. And you do have to memorize this. On the test, though, you'll be able to put it on the test, but for the quiz, you're going to need to know it. That's why pick your wise partner. The formula goes like this. A squared equals B squared plus C squared. Where'd that come from? Where do you think? Pythagorean theorem. Okay, so it's got a little Pythagorean theorem in it. Minus 2BC, that's these 2, times the cosine of angle A. So if I want to find side A or I want to find angle A, this is the formula I use. A squared equals B squared plus C squared minus 2BC times cosine A. Well, what if I want to find angle B or side B? I'm going to go like this. B squared equals, what do you think these 2 would be? Oh, minus 2AC, these 2, times the cosine of angle B. What if I want to find C squared? Again, these are very easy formulas. A squared plus B squared minus 2AB cosine C. So these are all 3 of these are the law of cosines. Again, you really only have to kind of memorize one and then just manipulate the letters. But this will help you find, if you have a side, 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 if you know all 3 sides of a triangle, you could find any of the angles using law of cosines. Or if you have a side, an angle in between another side, you can use the law of cosines to find any other side or angle. All right, so we just got 2 examples, and then I'm going to talk about this case called ambiguous case, and then we'll be done. Very easy today. So here's a triangle. I'm going to put 4 here. This is not drawn to scale. I want you to find X. Okay, so if I'm looking at this triangle, I'm given a side, an angle in between, and another side. Side, angle, side, you use law of cosines, okay? Since they call this X, it's up to you. You can call this whatever letter you want. I'm going to call this actually side A. And that means this angle would be angle A. Well, then which one do you call B and C? It doesn't matter. So I'm going to call this little b and this little c. And the way to memorize these formulas, because you're like, oh, so much memorizing in math, but if you just always write the formula again, you'll start memorizing them. So I'm going to start off by writing the formula. A squared equals B squared plus C squared minus 2BC cosine A. And I'm just going to start plugging in my numbers. So A squared, I don't know. B squared is 160 squared plus 170 squared minus 2 times 160 times 170 times the cosine of 4 degrees. By the way, make sure your calculator is in degree. You could right now depending on how your calculator will, you can type all this in right now. If you type it accurately and you're in degree mode, you'll get this correct part for me. Let's see if you do. Let's see if you get what I get. I mean, use parentheses. I would put parentheses here. 2 times 160 times 170 times cosine of 4. I got 232.516. Did you get that roughly? If you type it all in. Now that is what a squared is. That's not what a is. What would you do to find a? Square root. Don't have to worry about the minus. You just have to worry about the plus because we're talking about the side. So take the square root of that. And I get 15 point, round to the nearest tenths, 15.2. So that one is really easy and very simple. Wouldn't you agree? Straight in, plug it in. Okay? Nice, nice stuff. Great to do on the SATs or ACTs. I think some of you are taking it this weekend. I mean, these formulas are going to be great for you. Law of sines and cosines. You can use them. All right, let's just do one more example of cosine law here. I want to find angle A. This one always messes up students, so I definitely want to do it real quick. A, B, C. I'm giving you a side triangle right here. I would go around and I would label all the correct sides. So this is angle A, this is side A, little b, and little c. If I want to find angle A, I use the A formula. And again, I like to write it out. It helps me memorize it. Minus 2bc cosine A. And now I just start putting my things in. So let's see. 22 squared minus 20 squared, equals 20 squared plus 16 squared minus 2 times 20 times 16 times cosine A. Okay. So this one you have to do a little bit different. You got to get what 22 squared is, which is 484. 20 squared is 400. 16 squared, anybody know what that is? 256. And then 2 times 20 times 16 is 640 cosine A. Okay, let me just stop right here because you all look up because this is where everybody gets the problem. Can I just put all these together right now? Why not? Why not? Because cosine A. This is not, you can't just straight, and I cannot tell you someone is going to do this. They've done, every year someone does it. They're like, oh, 400 and 256 and then minus 640. You can't do that. This is being multiplied by cosine A. You can put these two together. That's 656, but you still can't put it here. You have to do what with that 656? Oh, you have to bring it over to that side. You have to subtract it over. So 484 minus 656 is negative 172 equals negative 640 cosine A. Then divide by negative 640, I get 0.26875 equals cosine A. How do I find A angle? What do I use? Inverse. So if I inverse cosine 0.26875, I should get my angle in degree. So second inverse cosine. And I end up with 74.4 degrees. I would round to the nearest 10th foot. Does that make sense there? Because everybody always messes that up. You don't want to add all these straight up together. This one you can just straight up add because you've got numbers and everything. So just put it all together. But this one, when it has a cosine A, you got to kind of add the first two, subtract it over, divide, and then find cosine A. Okay? Easy so far? All right. One more thing to talk about. I usually don't talk about this every year. I kind of just touch on it, but I'm going to bring it up this year. Hopefully it'll help you at one point. If you don't understand this, it's really okay. You're not going to be tested on it unless it just happens to be in the higher level math that you're going to, but I've only seen it on like one entrance exam test. I don't know why they did it for one of my students, but I helped them out with it. I was like, oh, great. There are what's known as ambiguous cases of law of sines and cosines. The ambiguous case of law of sines and cosines. So let me explain what happens. Do you remember back in geometry when you had side-side angle, not to be referred to what it is backwards? Okay, you are not allowed to have side-side angle. Did you know that in geometry, remember? Okay, back when I was in public school, if they wrote this on their test, I said, you are one. It's very mean. It was very mean. I'm not like that anymore. I have Jesus in my heart. Okay, if you end up with a side-side angle, nothing. If you get an A here, let's say ABC, let's say this is a 12.8, this is 58 degrees, and this is 11.4. What could end up happening is, think of this like a hinge right here. Like you could put your finger right at C, and I, of course, drew this completely inaccurate, but you can actually redraw another triangle. You could have 12.8, 11.4, and then the 58 degree here. You could also, that 11.4 might not even touch here. That was like your third possibility. There was, again, go back to geometry. I know it's been a while, but you had all these like triangle inequality things that could happen. So when you end up with an SSA case, you could have the possibility of one triangle working or two triangles working or none. And that's what we're going to talk about today. What happens if I end up getting this side-side angle, which is what I have right here. I have a side, and I have an angle, okay? So it looks like I should be able to do law of sines, right? Because I have an angle and its opposite side. Well, we're going to do law of sines. We're just going to see what happens if we do law of sines on this one right here. So we're going to try. Oops. God bless you. Law of sines. So we're going to write what? What's the law of sines say? Go back to what you did a homework on Friday. What over what? Sine of 58 over 11.4 is equal to, let's find B. Sine of B over 12.8, right? This is what we did. All right, we crisscross multiply. You'd get 11.4 sine B equals 12.8 sine 58. Divide by 11.4. You get sine of B equaling, I'm just going by what I have in my notes, so hopefully it'll work out. 0.9522. And then you inverse sine it. And you get B to B, I'm going to give it to you, 72 degrees. It's like 72.2, but we're going to go there. Okay? All right, well, this is our problem. This could be 72 degrees. Yes, it could be. Okay? But now, it could also be something else. Here's what I mean. Go back on your unit circle. If you have an angle in this quadrant that's 72 degrees, where else is sine positive? What other quadrant is sine positive? All students, right? You could have a 72 degree angle there. What actual angle is that, though? If this is 72 degrees here, what's that actually hitting on the unit circle? What are you doing in your head right now? You should be. Subtracting from what? 180 from 72 is 108. B could be 72, but if I take the sine of 108, I'd also get 0.9522. The sine, I mean, do it right now. Sine of 108, 0.951, okay, but close. 95, roughly, same thing. So we have a problem here because we have what is called ambiguous cases. So we could get the same thing over again. So what you have to do I'm not going to force you to do this except on one problem. So don't freak out about this. It's just really one problem. You're actually going to try a case as if it was 72 degrees, which we just found, but you're going to try a second case. We're going to call this case 1, where B is 72 degrees. And we're going to try a second case, whereas if B was 108. Again, where did I get that 108 from? 180 minus 72. So I'm going to try it as if B was 108. So let's let B be 108 degrees. And now I have 58. Let B be 108. And I'm going to find whatever, side C, something like that. Well, I didn't finish solving this problem. That's why we haven't done it correctly here. 11.4, 12.8. What would that make angle C? No, 14. 14. Okay. So then I would say, okay, so sine of 58 over 11.4, I always go back to my original, equals sine of 14 over C. And I crisscross multiply, and I get, let's see, 4 divided by sine of 58. And I get C to be roughly 3.29. Well, let's do it as if B was 72 and find C, side C also. That was what I was trying to do. That's what I didn't do at first. I'm sorry about that. Boom, boom, boom. 72, 58. What would that make angle C right there? 180 minus 58. 50. Thank you. You are right. You got it. Okay. So sine of 58 over 11.4 equals sine of 50 over C. And you crisscross multiply, and we get, bear with me because I can see you're all furiously doing this. I know. 10.26. Okay, so here's what happened. Here's the whole point of this. The problem is there's two possible triangles here. I could have a triangle that has a length of C. The C could be really, really long because obviously C is a really big angle, or it could be really, really short. It could be 3.29. So I could have two possible triangles. Sometimes you only would have one possible triangle. It won't work out on the other one. And sometimes neither of them will work out. There's just no way you're going to get any triangle because it's going to be like short and not touch the other side. Okay. So this is called the ambiguous case. Again, I haven't seen it except, like I said, one time somebody was like, can you help me with this practice problem? I haven't seen it on ACTs or SATs. I just want you to be aware though, it can happen. So it's going to happen on homework tonight. Don't freak out about it. But if you go to your last page in your packet, I'm going to be very nice to you right now.